Okay, let's take a look at the product rule for logarithms. The product rule looks like this. If you have the logarithm of a product, so you've got log base a of m times n, where m and n are both real and m and n are both positive, so that the logarithm exists, then you can split that up into two logarithms, log base a of m plus log base a of n. Now that actually looks a little weird. Let's do a couple of examples first of how that would work before we spend a little time talking about why this is true. So for example, log of 3 plus log of 7 equals log of 21. So for example, I can use the right-hand side and say if I have the sum of two logarithms, it's going to be the logarithm of the product. Similarly, if I have the natural log of 3x, where x is a positive number, to make sure that that logarithm exists, I can split it up into ln of x plus ln of 3, or ln of 3 plus ln of x. I'm going to scroll down a little bit, and let's talk about how this works. This is not a proof by any stretch of the imagination, but it is a little strange to try to work with this rule. So let me give you an example that might help you understand why this isn't actually as weird as it looks. If we write down what log of 4.2 is, we find that it's 0.623249. If we take a look at the log of 42, it's equal to 1.623249. Log of 420 is equal to 2.623249. And I think you can see a definite pattern developing where logarithm of 4200 is equal to 3.623249. So let's actually split the right-hand side up into two bits. Even if you don't quite understand where I'm going with this, I think you'll agree that this is a legal move, that 3.623249 is equal to 3 plus then all those decimals. But the interesting part about that is that the 3 is actually equal to log of 1,000. Think about it. The exponent on 10 that gives 1,000 is 3, and we can see from just up above, let me highlight it here, that that's just the logarithm of 4.2. But on the left-hand side, the log of 4,200, so let's just make a little note here that we're just fiddling around with the last one, the log of 4,200 is equal to the log of 4.2 times 1,000. And so I think you can see here that when I have a product inside the logarithm, it's equal to the sum of those two logarithms. Again, you have to make sure that everything's nice and positive and that everything's legal. And just to remind you also that there's one other place where we've seen a property that's similar to this, and let me just scroll down a bit, is that if we make a note, what happens when we have a product of bases like this? When the base is the same, we found that we can add the exponents. That's one of our exponent rules. So when we have a product on the left-hand side, then we have a sum in the exponents. So that's a very similar property to the product rule that we've just looked at.